Welcome to this MedEWSa short video about why we should use the risk matrix. In this video, the main benefits of using a risk matrix for impact-based forecasting and warning will be outlined. Let's get started. So, what are the benefits of using a risk matrix? As explained in the What is a Risk Matrix video, the risk matrix is a powerful communication tool for early warning because it conveys both the potential impacts of a given event and the likelihood of those impacts occurring. The two elements of impact and likelihood are combined to define an overall risk level. In our example, a medium yellow level of risk means that the person in danger should be aware of the hazard and track how it evolves. In addition to conveying the level of potential risk through an action statement, the overall risk level can be displayed as warning maps to determine the approximate location of a given event. For example, here are some snow and wind warnings issued by the UK Met Office. Because the risk matrix is built around impacts, these warning maps have clear predefined links to what the public can expect to happen during an event. Impact descriptions provided for the red, high wind category indicate that the public should expect widespread danger to life from flying debris, widespread structural damage to buildings and infrastructure, and disruption to transport links, thus informing the user of the potential effects of the high winds. In weather forecasting, it is usual that when we get closer to an event in time, the more confident we will be that the event will happen. This is also similar for impact forecasting, where the likelihood axis on the risk matrix is used to describe the confidence we have in potential impacts occurring as we approach an event. Our confidence in a forecast is especially important for hazards that could potentially have high impacts, because it allows extra time for people to prepare or take action before an event. One way to quantify the likelihood of a forecast is to generate several forecasts from a set of initial conditions. This is called ensemble forecasting. Each forecast member simulates a possible future scenario. When looking at all members together, we can assess the range of possible future scenarios. In general, the range of scenarios we forecast reduces with lead time as we get closer to the event start, meaning that our confidence in the forecast increases. In other words, the most likely scenario becomes clearer the closer we get to the event. Another benefit of using a risk matrix is that it provides a way to track the evolution of the potential impacts that could affect our warning space as we get closer in time to a potentially impactful event. Let's look at an example. In June to July 2015, a heat wave impacted much of Western Europe. To illustrate, we will look at the 2-meter air temperature forecasts by MedEWSa on the 1st of July for Paris. The graph shows the forecasted temperature range issued from early June. The range of temperatures for the 1st July from the climatology of the last 20 years gives us a reference for what temperatures could be expected for this event. On the graph 1 month before the event, the forecasts do not indicate temperatures out of the ordinary range. Brown stars indicate that the median of the forecast ensemble is within the observed range, and the bars, which indicate the spread of the forecast uncertainty, are quite large. As we move closer in time to the event start, we start to notice changes in the forecast. 14 days before the event, the stars start to be consistently above 23 degrees, suggesting hotter temperatures than normal, but still associated with considerable uncertainty. 10 days before the event, more ensemble members begin to indicate temperatures above 23 degrees, even reaching 30 degrees. This means that the majority of the forecasts suggest hot temperatures, thus increasing the impact category on our risk matrix. But we still have low confidence. 8 days before the event, the forecasted temperature continues to rise, but the range of the ensemble forecasts becomes more focused, increasing our confidence in the forecasts. Finally, on the 26th of June, just 6 days before the event, the forecasted temperature is now around 35 degrees, with the ensemble members becoming even more focused. This means that extreme temperatures are very likely to happen and will have a high impact with high confidence. Detecting change in confidence levels as an event approaches is beneficial for effective early warning. The risk matrix can also be used for mitigation of impacts and response to a given event. In the example, specific categories on the risk matrix are linked to actions which can range from continuing to monitor the forecast over the coming days to evacuating people from their homes as the event becomes imminent. The benefit of these predefined actions for effective early warning is that in the time-sensitive and pressurized situation building up to a potential event, decision-makers already have a clear process on how they should prepare or act, depending on the risk level. The final benefit of using a risk matrix is the ability to communicate low-likelihood warnings that may be beneficial for hazards where our predictive capabilities are poor. For example, during a thunderstorm, it is extremely difficult to know exactly when and where convection will occur, due to the complicated physics and the fact that the cells can be isolated in time and space. So, our ability to issue impact warnings with the risk matrix, even when we have low confidence in the forecast, can be valuable for hazardous events such as surface water flooding from convective rain or thunderstorms. That concludes this video on why we should use a risk matrix. If you would like to find out more about what is a risk matrix and how to build a risk matrix, watch our other videos in this series. We hope you enjoyed this MedEWSa short video. Thank you for listening.